Hi there. This is the second in a series of videos about analyzing functions numerically from tables of data. In this video, we'll focus on exponential functions, and I chose the example y equals 2 to the power of x. The term exponential refers to a function that involves a power where the variable is in the position of the exponent. That's why it's called an exponential function. Let's generate a table and then analyze that table in order to understand how exponential functions behave. So I'm choosing some simple inputs, and we'll see what outputs the formula produces when I plug in the numbers 1, 2, 3, and 4. And here we go. 2 to the first power is just 2. 2 to the second power means 2 times 2, which is 4. 2 to the third power means 2 times 2 times 2, which is 4 times 2, which is 8. And 2 to the fourth power is 2 times 2 times 2 times 2, which is actually 4 times 4, which is 16. So for inputs of 1, 2, 3, and 4, this formula produces outputs of 2, 4, 8, and 16. Now the interesting thing to notice about the y values for this function is that in each case the y value doubles. And that's not hard to understand if you think about the fact that we have 1 2 and then 2 2's and then 3 2's and then 4 2's. So it actually makes sense that the y values are doubled when you go back and connect it to the work that we did to produce the y values. That observation is true in general for exponential functions. So the result is here. The table for an exponential function will show a constant ratio in the y values. The term ratio is used here because if you do division, 4 divided by 2, you get 2. 8 divided by 4 also produces 2. And 16 divided by 8 gives 2. Another way of saying that is that the ratio of 16 to 8 is 2. So people say the y values are in a constant ratio. That statement is again true in reverse. Any table that has that property of having a constant ratio between consecutive y values must represent an exponential function. So if you come across a table and all you know, let's see if I can scoot things around here. If all you know is that the function has these values and you don't know the formula for that function, you can still know that it represents an exponential function because it has this property right here. Hope that helps, and thanks for watching.